Hello, welcome to Flipped. Today we are on electrolysis of dilute solutions using carbon electrodes. Difference between this electrolysis setup and the one we talked about for molten ionic compound is that selective discharge will be important here. We have to choose the correct anion and cation to be discharged. Okay, so let's take a look at the setup. Okay, we have dilute NaCl solution. This hints that there is NaCl, of course, so there's Na plus and Cl minus. And the word solution and dilute hints that there is H2O, which will be ionized into H plus and OH minus, because this is water, right? H2O, which will be ionized to H plus and OH minus. And there's carbon electrode, which means it's just carbon, which is inert. So we do not involve them in the reaction at all. Okay, so this can be left out essentially. So let's go to this one directly. So this is a standard template you can use in your exams, okay, and your practices, because this one will always be correct. Okay, so attracted to cation, we just put all the pluses, okay, all the positive ions, which are, you can see that there's Na plus and there is H plus, am I right? Whereas attracted to anode, which are the negative ions, we can see that there's Cl minus and we can see that there's OH minus. Okay, if you recall, based on the video of our rules for selective discharge, we know that for cation is based on the reactivity series, which is based on this mnemonic that we have come up with. Please stop calling me a colored zebra. I think leaders have cool silver glasses. Okay, it's a bit long. Okay, it's taking up the whole screen, but you can see that we just need what we need. Correct? We can see that sodium is here. Okay, we can see that H plus, you can see that H plus, yeah, it's here, hydrogen is here. So, and I told you that this one will be hard to discharge, whereas here will be easy to discharge. So, can you guess which one we will be using? Okay, we'll obviously be using hydrogen, because it's easier to discharge than sodium, which is all the way up here. Okay, so for the cation, we'll be choosing H plus. What about anode? Okay, anode are anions. We determined that to choose the correct anion, we have to see whether it's concentrated or not. In this case, it's dilute, so we just choose the default, which is OH minus. Okay, so far we have chosen H plus and OH minus. So now we have to go into their individual reactions. We can see that at at cathode first, we'll have 2 H plus aqueous, plus 2 electrons to give us H2 gas. Whereas at the anode, it's 4 OH minus aqueous to give us O2 gas plus 2 units of water, liquid, plus 4 electrons. Okay, so if you're wondering how can you derive this, at all the way just from OH minus to whatever is being needed, I can just tell you that you can just memorize this. Okay, these two are up for memorization. It's easier that way, I feel, because you will not instinctively know that OH minus will become O2 and H2O. Okay, so I think the best way I recommend you to study for this chapter is that you have to memorize what is happening with H plus and what is happening for OH minus. Okay, so based on this, we know the observation. Cathode, we can see that bubbling of H2 gas, is here, is being observed. And for the anode, bubbling of O2 gas is observed, oxygen. Okay, overall equation, we have learned how to do this already. So we can see, we have to compare number of electrons of both reactions. First one, we see that there's only 2 electrons. There's 4 electrons here. So what do? I have to times 2 to everybody. What do I get? I'll actually get this guy. Let me change color here. Purple maybe. Okay, I will get 4H plus aqueous plus 4 electrons. Okay, so now it tallies with the 4 electrons here to give me times 2, right? So it's 2 H2 gas. Okay, my next step would be to cancel them out. So I have 4 electrons here. I cancel this guy. I cancel this guy. Okay, obviously you don't cancel the one that you have written if this is awarding marks. Okay, you have to rewrite this whole thing. But if you're just asking for the overall equation, you can do working on this, no problem. Okay, but anyway, once we have cancelled these 4 E's now, okay, 4 electrons, we can just combine whatever is on the left hand side and whatever is on the right hand side. Let me write it down for you. Left hand side, what we have is 4H plus, alright, 4H plus equals plus, okay, anything else on the left hand side here? Nothing. What about here? There is 4OH minus equals anything else on the left hand side? Nothing. Let's move on to the right hand side then. Let's begin with here to give us 2H2 gas plus, okay, anything else? Okay, right hand side is this one, right? O2 gas plus 2 units of water liquid. Okay, so you might think that's all to it, okay, but we have learned that if there are pluses and minuses on the same side, okay, they can actually combine. And just nice, there are 4 units of each, okay, plus and minus. So we can just combine them to simply 4 units of water, okay, to give us the same thing here. We just copy out plus O2 gas to give us 2H2O liquid. Okay, so you might think, okay, finally that's the end of it, right? Sorry, no, just one more step. Because this is a bit of unique situation. Because we can see that H2O, okay, liquid, they are present on both hand sides. So what we want to do is, in some sense, we have to simplify this equation. So what we can do is now we have to cancel this to become 2. This one totally cancel out. Okay, so we are in some sense simplifying. You can imagine we are removing this H2O by bringing them to the left hand side. So we are minusing them away. Okay, what we'll finally get, okay, I promise you this is the last one, is 2H2O liquid to give us 2H2 gas plus O2 gas. Okay, you can see that this is the final reaction, and this makes sense because water is used here. Only water is used. Any Cl is not used at all. It's just there. So water is being changed, okay, in some sense into H2 gas and O2 gas. Okay, water is here, but it's not here because it's being cancelled away with the 4H2O. Okay, so this is called the overall reaction. And you can see that in terms of ratio, we are forming 2H2 is to 1 O2. Okay, this is just clear from the number in front of the respective substance. Okay, so let me give you another example. This is using dilute nitric acid solution using carbon electrodes. Let's unpack this. Dilute, so we know there's H2O involved. Carbon electrodes means it's inert. I don't have to care about it. Okay, nitric acid, okay, is actually HNO3. Okay, dilute means just dilute, right? So let's talk about what's at the cathode. Cathode is attracting all the pluses, right? All the positive ions, which in this case is, okay, because we know solution means there's H2O. Okay, H plus and H plus. So I don't have to write them. Okay, I can write it out again. Okay, this H plus belongs to the H plus for HNO3, and this H plus belongs to the H2O H plus. Okay, but ultimately I'll just choose H plus because it's the same thing. Whereas for anode, okay, I know there's OH minus based from my H2O. There's also NO3 minus from my nitric acid. Okay, so nitric acid is essentially H plus NO3 minus. This one is a memorization thing. Okay, you have to memorize the common acids such as nitric acid, sulfuric acid, hydrochloric acid. Okay, so once you memorize, you know that it's HNO3, H plus, NO3 minus. Okay, so you can break them up into H plus and NO3 minus. So ultimately, we have to choose what is to be the reaction to happen at cathode and anode respectively. Cathode, there's not much choice. H plus is H plus. Okay, so we just choose whatever, which one we prefer, H plus. Okay, actually you can just ignore this step actually, but I write it down to show you that it comes from both of them. Anode, okay, we know that the default is OH minus unless it's concentrated. Okay, but it's not concentrated in this case, and we do not choose nitrate anyway. Okay, we only choose Cl minus, I minus, and Br minus, the halides, if they are concentrated. Okay, so in this case, they are not concentrated and they are not halides. So we just choose this guy instead. Okay, quite simply. So this one you can see that is exactly what we have done here. Do you realize? It's exactly the same thing. So whatever is here, we can just copy and paste. Okay, so you can see that at the cathode, it's exactly the same thing. 2H plus equals with 2 electrons. This is a reduction process to give me H2 gas. Whereas for anode, it's 4OH minus aqueous to give me O2 gas plus 2 units of water, liquid, plus 4 oxygen. 4 electrons. Okay, this one, maybe I forgot to talk about this in the previous part, but we've talked about in the previous video, is this thing called ORAC. Okay, oxidation, okay, which is the act of releasing electron, always takes place at anode. Okay, you can see the anode is oxidation. That means to give out electrons. Whereas reduction always takes place at cathode. So cathode, you can see that reductions is defined as taking in electrons, right? So you can see that it's taking electrons here and it's at the cathode. Okay, so this is something you can remember to help you with your this chapter. Okay, oxidation is always at anode, reduction R is always at cathode. Okay, so overall reaction, I will not go through the whole thing again. You can refer to the previous part. So I'll give you the final answer. It's the same as what's above because we are using the same substance. Am I right? So 2H2O liquid to give us 2H2 gas plus O2 gas. So it's the same thing. We can see from the equation that H2 is formed in the ratio of 2:1 compared to oxygen. Okay, and finally, let's just sum it up. Electrolysis of dilute NaCl, as we have seen above, or dilute acid, as we have seen here, is known as electrolysis of water. Okay, so it doesn't matter what we use. Okay, we can use dilute HCl, dilute HNO3, dilute H2SO4. Okay, doesn't matter. That as long as it's dilute acid, it will just choose water nonetheless. Okay, because only water is discharged in the case of H plus and OH minus. Okay, so all components are being discharged. Okay, so but this one is a bit special because as the experiment continues, water will continuously be removed. As you can see from the overall equation, H2 will be slowly turned into gas and gases, H2 and O2, and will bubble out at cathode and anode respectively. So they'll be removed continuously, and NaCl, okay, which is what we are talking about previously, sodium chloride, and acid will slowly increase in concentration, and that will have an impact on the whole electrolysis setup, okay? Because when it's increasing in concentration, recall that we have learned that if we use the concentrated concentrated acid, for example, with the halides in it, they will take precedent over OH minus, which is the default. Okay, we will talk about this more in the next video, where we will discuss electrolysis of concentrated, okay, solution using carbon electrodes. Okay, that will be the next video.